Hi, I am Kester that studied in CSC A section. I am explaining about Tech Talk subject is flat. What is automata? A term automata is derived from the Greek word which is meaning of self-acting. Automaton are abstract model of machines that performance computations of input by moving through a series of states. Finite automata. An finite automata with the finite number of states is called a finite automata. FA is finite state missions. Formal definition of finite automata, and finite automata can be represented by 5 tuples Q, sigma, alpha, Q naught, F, where Q is a finite set of states, sigma is a finite set of symbols or alphabet of a automaton. Alpha is a transition function. Q naught is a initial state from where any input is process of. F is a set of final state. Next one, example of finite automata. See the diagram, easy to. A is a initial state, last one is final state. It is a transition function. The circle represented as a states. The arcs labeled within the input alphabet shows in the transitions. The initial state is denoted by the empty single incoming arc. The final state is indicated by double circles. Q is a ABC, sigma is a 0, 1, Q equal to A, final state is C. Structure of finite automata. This is the structure, easy to understand. Tape, finite control, read, write, final memory. Next one is structural representation. Finite automata represented in two ways: transition diagram, transition table. This is the transition table. State inputs, easy to understand. So, transition diagram. Transition diagram or state transition diagram is a directed graph which can be constructed as follows. There is a node for each state in Q which is represented by a circle. There is a directed edge from node Q to node P labeled if epsilon sigma alpha Q comma A equal to P. In the start state there is an arrow with no source. Accepting states are final states are indicating by a double circle. Next one is state Q1, transition from state to one state to another state. It is symbol start state, final state. This is symbols. Next one is transition table. The transition table basically is tabular representation of the transition function. It makes two arguments, a statement and a symbol, and returns a state, the text state. The transition table is represented by a following things. Columns corresponds to input symbol, rows corresponding to states, entries corresponds to next state. The start state is denoted by an arrow with no source. The accept state is denoted by star. This is the diagram. See, transition table, transition diagram, easy to understand. Inputs, states, transition, moves one place to another place. Outputs. Chomsky normal form. Chomsky normal form in 4 types: regular, context-free, context-sensitive, recursive, enumerable, as a tabular form. Grammar, language, automata. Type 0 is recursively enumerable Turing machine. Type 1 is context-sensitive, linear bounded, non-deterministic Turing machine. Type 2 is context-free, push-down automata. Type 3 is regular, finite state automata. Alphabets, strings, language, problems. Alphabet. An alphabet is a finite collection of symbols. Example, sigma A comma B is an alphabet, 0 comma 1 is an alphabet. Sigma A, B, Z, B an alphabets. Set of lowercase letters. String. A string over an alphabet. Sigma is finite sequence of symbols of sigma. Example, let sigma equal to a comma b an alphabet, then a b a b b b b a b a b a are some examples of string over sigma. A finite infinite number of strings can be generated. Let sigma equal to 0 comma 1 be an alphabet, then 0 1 0 1 0 0 1 or 0 0 1 0 1 and 0 1 1 0, etc. Language. It is a collection of an appropriate string. Example. Language, there is a set of strings over 0 comma 1 that starts with 0. Language is any numbers, this is starts with 0 0. Example, 0 0 0 and 0 1 0 0 1 1. These examples are starts with 0. A set of all strings over a b c having as a substring. AC as a substring. So every example AC is in compulsory. AC is compulsory. Since language are sets, we can apply various well-known set operations such as union, concatenation, clean star or clean closure, complement, difference, insertion are languages. Type of finite automata. Two types of finite automata. They are deterministic finite automata DFA, deterministic finite machine. Non-deterministic finite automata. Finite automata with output. Finite automata without output. With output lo Mealy, Murray missions. Without output DFA, NFA, epsilon NFAs. DFA. Formal definition of an DFA. A DFA can be represented by an 5 tuples Q, sigma, alpha, Q naught, F, where Q is a finite set of sets, sigma is a finite set of symbols called as alphabets. Alpha is a transition function where alpha equal to Q into sigma equal to Q. Q naught is the initial state from n where any input is processed. Finite states. Graphical representation of DFA. DFA is represented by a state diagram. The vertex is represented as the states. The arc labeled with an input alphabet shown in the transition. The initial state is denoted by an empty string incoming arc. The final state is instanted by a double circle. Next one is NFA. NFA can be represented by an 5 tuples Q, sigma, alpha, Q naught, F. Q is an finite set of states, sigma is an finite set of symbols called as alphabets. Alpha is a transition function where alpha equal to Q into sigma into 2Q. Here the power set of Q, 2Q has an token because in case of non-deterministic finite automata from state transitions can be occurred any combination of an Q states. Q naught has an initial state from where any input is processed. Final set of states. F has a final set of states. Graphical representation of NFA. The vertices representation states. The arc labeled with an input alphabet shown in the transitions. The initial state is denoted by an empty single incoming arc. The final state is denoted by a double circle. Thank you. This is my Tech Talk topic.